Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the Space Nuts podcast, our first get-together for 2018, and we welcome back from the Australian Astronomical Observatory, Fred Watson. Hi, Fred.
Hi, Andrew, and Happy New Year to you and all your family and colleagues and the universe around you.
My family is more widely distributed now. One of the things that I did over Christmas was kick my youngest son out and move him off to Sydney. So we're empty nesters for the first time in 29 years. Hard to believe.
That'll be a shock to the system.
It is a real shock. You know what's strange, Fred? I still hear him around the house when I'm home by myself.
Just the ghost of your son.
Yeah, and I drive up the hill because we're on the top of a hill where we live, and I kind of am taken aback every time his car's not there because it's always there and has been for a few years, but not anymore.
Yeah, sad. It's a big change, and probably who knows? One day you might be completely infested with grandchildren. So
that's happening already. Yeah, we've got the first birthday of the granddaughter today, so
there you go.
It's already happening.
Happy birthday, yeah.
Now, today, Fred, we're going to be looking at the creation of the world's biggest telescope, and they've already built some segments for it, which is very exciting. This is one massive piece of equipment. One of the other things we'll talk about in a moment is this lunar eclipse that happens at the end of this month, and it coincides with a blue moon. So we've got a combination of factors that haven't been seen for, well over 100 years. And a Japanese astronaut who reportedly grew 9 centimetres while he was in space for 3 weeks, but turned out not to be quite 9 centimetres. But we'll talk about that. It's an amusing story. But first, Fred, let's have a look at this lunar eclipse due to happen at the end of the month and visible in the Asia-Pacific region, and that includes those of us in Australia. So this lunar eclipses are always spectacular. I love them.
This one especially, Andrew, because certainly from Australia, most of us anyway, will see the whole eclipse. The whole event from the start of the moon's outer, I beg your pardon, let me rephrase that. The whole event from the start of the Earth's outer shadow, because of course it's the shadow of the Earth that passes over the moon in a lunar eclipse. What we call the penumbra, which is the outermost part of the shadow of the Earth. If you were standing on the moon and the moon was in the penumbra, you'd still be able to see a little bit of the sun. It wouldn't be completely dark. Whereas in what's called the umbra, which is the deepest part of the eclipse, if you were standing on the moon, you wouldn't be able to see the sun at all. Although, if you were standing on the moon during the total eclipse, what you would see is a brilliant ring of red light around the dark Earth. So the Earth's in between you and the sun if you're on the moon, but the Earth's atmosphere scatters the light around into the shadow of the Earth. And because the scattering process basically prefers blue light is scattered much more acutely than red light, and that's actually why the sky is blue.
So it's a sort of a huge sunset effect.
It's exactly like that. That's right. It's just a global sunset. So you've got this red rim around the disk of the Earth. This is assuming you're standing on the moon, which not many of us will be, but it's a thought experiment. But it's that causes the red glow on the moon, which we see from the Earth. When we see one of these total eclipses of the moon, often when the moon is deep in the Earth's shadow, you don't just see blackness, which is what you would intuitively expect. You see this deep coppery red glow. It's sometimes called a blood moon, and it's caused by this scattering of light on the atmosphere. And that is something, given clear skies, that we expect to see in the eclipse on the 31st of January. And maybe I can just give some times for that, Andrew. It does vary depending on where you are in certainly in Australia and in the whole Asia Pacific region. So maybe the best thing I can do is to give you two sets of times, one of which are what are called universal time, and that's effectively Greenwich Mean Time. It means the eclipse starts at 12:51 Greenwich Mean Time, and that's 12:51 in the middle of the day.
Yep.
And it basically ends at 14:07. 7 minutes past 2 in the middle of the day. But of course, that's Greenwich Mean Time. You've got to add your time zone difference. So for us, in actually New South Wales.
Yeah, I'm just working it out in my head. I think at this point in time we're like 11 hours ahead, aren't we? And
that's correct, because of daylight saving.
So it's going to be...
It's 11:51.
Late at night.
Exactly. 10 minutes to midnight is the start of the total eclipse. That's when the penumbra, the moon is exactly in the penumbra, and 7 minutes past 1 is when the moon comes out of the penumbra. The partial eclipse, the penumbra, what's called the... I beg your pardon. Let me say that again.
We're a bit rusty. I mean, let's...
Yeah, God, I'll tell you. Yes, the 2 weeks off, and what happens? I can't speak English. The 11:51, 10 minutes to midnight, or 9 minutes to midnight, the moon will be in the umbra of the shadow of the Earth. In other words, the dark part. That is when you'll start to see the coppery blood moon, and it comes out of that phase at 7 minutes past 1 in the morning on the 1st of February. So maximum eclipse is actually roughly 12:30, half an hour after midnight. That is in Eastern Australian daylight saving time. So that's what we have in New South Wales. Of course, if you're in Queensland, it'll be an hour earlier, and progressively across the country, a couple of hours earlier, in fact 3 hours earlier in WA.
So most of Australia will be able to see it in totality. New Zealand, of course, eastern parts of Europe by the look of it, and northwestern parts of the United States will be able to see totality.
That's right. There won't really be that much to see from Europe. It will be, just the partial phase. They won't see much at all. But from Eastern Asia and from the far northwest of the USA and Canada, so Alaska will also see it pretty low on the horizon from those latitudes.
Yeah.
But we get a good view. Hawaii gets a brilliant view as well. So an interesting eclipse. And what makes it doubly interesting, and this is more a calendrical phenomenon than an astronomical one, it happens on what's called a blue moon. And you and I think have talked about blue moons before.
We have, yeah.
It's a as I said, it's a calendrical event rather than any.
It means calendar, as in date. Calendrical. I think you're making that up.
It's a great word.
Is it a word?
Well, all right. Try another one. Calendarological. How's that?
That'll do.
No, I don't like that. I like calendrical better.
Yeah, that's a good one. I do like it.
It means, as ladies and gentlemen, if you're listening to this podcast, as Andrew said, it means to do with the calendar. Good thing both of us are here to explain what the other one's talking about. So it's to do with the calendar, quite so. And there are various definitions, actually, of what a blue moon is. And I think the original definition comes from something called the Farmer's Almanac, if I remember rightly, which was an American publication, I think in the period between the wars. I haven't looked at this stuff for a while, but it was, during the early part of the 20th century. But their definition then was that the blue moon was the third full moon of a season that has 4 full moons in it.
Wow.
Yeah, I can see the wheels going.
Yeah, I'm just trying to
So just think about this. So
Because we've had a couple already.
yeah, we have. Yeah, blue moons are not that uncommon, but this one is, as I'll explain very shortly when we finally get to that bit. So if you think about the season, an astronomical season, that's to say, spring, summer, autumn, winter, you would normally expect, because it's 3 months, you'd normally expect there to be 3 full moons in that period, because the moon is full roughly once a month. But if you've got a season that has 4 full moons in it, apparently the third one was called the blue moon, and that must go back to North American tradition. But it's now, the definition has now changed. It's shifted, I guess, in the last 40 or 50 years, and we now describe a blue moon as being the second full moon in a calendar month.
Yeah.
So if you've got a calendar month which has 2 full moons in it, then the second one is a blue moon.
Now, that doesn't count if they're 2 full moons 2 nights running, though, does it? Or is it?
Well, that's a good point, because we tend to think of the full moon as just being this vague time around part of the month, and usually when you look at the moon, you can't tell the difference between the actual night of full moon and what it looks like the next night. But the full moon itself is defined very precisely in astronomical terms, and it's when the moon is exactly opposite the sun, as seen from the Earth.
So that only would happen.
So there's only one. That's right. So there's only one of those in a month. There's only one of those in a lunar month. But then you can, because the moon goes around the Earth or actually because the interval between 2 full moons is 29 and a half days. It does mean that from time to time you can get 2 full moons within a month. And that's what we call a blue moon. Now, there's a peculiarity about this, because on the 31st of January, throughout all of Australia except the bits where we are, the full moon occurs on the 31st of January. And there was one already on the 2nd of January. So
I see where you're going.
You can see where I'm going, because that's the curiosity. In Sydney and in New South Wales and in Victoria, the time zone, Eastern Australian Daylight Time, actually the second moon is in the small hours of the morning of the 1st of February.
So it's not a blue moon for us.
So it's not a blue moon for us. No, that's right.
Oh, wow. This is really good.
Yeah, it's pretty weird. But, for those places where it is a blue moon, that is what makes this curious, because this is actually the first blue moon total eclipse, because the eclipse will happen everywhere. That's something that's not determined by the calendar. That's an astronomical phenomenon. But the blue moon, so where there is a blue moon, and that's parts of Australia other than Victoria and New South Wales, that is your first blue moon eclipse for, wait for it, it's 152 years.
My word.
So
and I'll add a little point to that. It does count in Queensland, even though it's on the eastern seaboard, because Queensland doesn't have daylight saving time, so it'll still be the 31st of January for them.
Yeah, so Queenslanders get the blue moon eclipse.
And of course, years and years ago, when they voted against daylight saving, this event was the reason. That's why. That's why
probably. Yeah, maybe that's right.
Yeah, that's it.
We want
Gotta
to
be
see
it.
the blue moon. Yeah.
All right. So
yeah, it's an interesting time. It's also not quite, but nearly a supermoon. And a supermoon is when you've got the moon full at the nearest point to the Earth in its orbit.
Okay.
The Earth's the moon's orbit around the Earth is elongated, so it has. Its distance varies from the Earth, and sometimes it's closer and sometimes it's further away. When it's at its closest, we give it the technical term perigee, and at perigee, if the perigee coincides with a full moon, we call it a supermoon.
Yeah, I think we had one last year, didn't we? Or 2?
We actually had one on the 2nd of January this year.
Oh, okay. Yeah.
Yeah. So that was, the 2nd of January was the supermoon. It's not quite a supermoon on the 31st of January.
Okay. You're not being attacked by plovers, are you? I can hear them.
Yes, that's right. They're outside. They're trying to get their heads wrapped around these astronomical phenomena.
Yes, well, it can be mind-boggling. But who would have thunk that the moon could be so fascinating in one fell swoop like this? But 31st of January into the 1st of February for some of us, but most of us will see it as a blue moon eclipse, first one in 152 years. For those of you in Central and Western Africa, Western Europe and the UK, and in Central and Eastern South America, tough luck.
You won't see anything. I guess there's a conundrum in this as well, just wrapping it up finally, in that it will be a blue-red moon during the eclipse because the moon will be blood red, but it will be blue.
So
work that one out.
Which makes it a purple moon. There you are. We've just renamed it.
Yeah.
You're listening to Space Nuts with me, Andrew Dunkley, and astronomer Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
Okay, Fred, I'm feeling a little bit hungry right now because we're about to discuss the ELT, which sounds very much like one of my favourite sandwiches. But we're talking actually about the extremely large telescope, and the reason it's in the news, to use your turn of phrase, is because they've started building the darn thing, which is exciting, very exciting.
It is, and it's this is perhaps one of the big milestones in the construction of this telescope. There's been a lot of work done already. I
figured there would be, but what we're about to talk about probably one of the more exciting elements of it.
It is, exactly, yeah. So the contracts have all been laid. The top of the mountain that it will sit on in northern Chile, a mountain called Cerro Armazones, that's already been flattened to kind of take the pointy bit off the mountain.
I still can't get my head around the fact they've knocked the top off a mountain. That just blows my mind.
Well, it basically is just earthworks, but you can tell when you look from afar at Cerro Armazones, which I managed to do a couple of years ago. You can clearly see that the top of this mountain is flat, and that is going to be graced by the biggest astronomical telescope in the world when it starts work in, I think, 2024 is the date. This is a European venture. It's being made by the European Southern Observatory, which you might remember Australia is now a strategic partner with, actually, European Southern Observatory. This telescope has a long and interesting history. It's what we call an ELT, which is an extremely large telescope. The original plan was that this telescope would have a mirror 100 meters in diameter, and it was going to be called OWL. And OWL stood for the overwhelmingly large telescope.
I was going to say outrageously large. But
Yeah, well, overwhelming. Yeah,
overwhelmingly is good too.
Yeah, basically they realised that would have an overwhelmingly large price tag, and so probably almost a decade ago now, I think it was downsized, but it still will be by far the biggest telescope in the world. It will have a mirror 39 meters in diameter, which is actually, I think, 3 meters bigger than the diameter of the dome of our Anglo-Australian telescope.
That's just
out there. near Coonabarabran in New South Wales. Now, a 39-meter diameter mirror, of course, this is a dished mirror. It's made very precisely. It's the biggest error on it is measured in basically the size of atoms rather than in millimeters or anything. But you can't make one a solid piece of glass or a glass ceramic material, which is what these mirrors are made of. You can't make one that diameter. So what they do, and this has already been done for telescopes up to about 10 meters in size, you make them of what are called segments. You segment the mirror. You use hexagonal pieces of this glassy material, and you butt them all together so that you've got effectively a contiguous glass surface. And the clever bit is that you keep them in place by computer-controlled actuators so that they maintain these hexagons in exactly the right position relative to one another, and that position is maintained no matter where the telescope is pointing, because, of course, as it moves around, gravity changes its dimensions.
Does having such a large mirror made up of such small pieces or smaller pieces affect its accuracy or its ability?
No, they don't, actually. That's a good question. And because the gap between these segments is virtually nothing, there is a tiny gap, it means that you've got effectively a continuous surface. And because of the efficacy of these computer-controlled actuators to keep the mirror segments in place, you can effectively duplicate what would be a solid glass mirror. There are slight artifacts that you would get caused by the boundaries of these hexagons, but that's a small price to pay for the fact that you can make a mirror 39 meters across. The big price to pay, well, these hexagonal segments are they're exactly 1.4 meters across, 140 centimeters, which means they're actually, each segment is bigger than the diameter of one of our telescopes at Siding Spring, the UK Schmidt telescope, which has a lens diameter 1.2 meters in diameter. So each one of these segments, 1.4 meters across, 5 centimeters thick, which means they're actually slightly flexible. And that gives you another level of control, because you can actually bend them slightly with these actuators to maintain the perfection of the shape of the glass. But the price you pay for all this is that, okay, that's one segment, 1.4 meters across. The telescope has 798 segments like that.
Wow, and how many of them have they made so far? Because that's why it's in the news.
The big news is that they've made 6.
6?
Actually, they've cast 6. They haven't yet done the optical fabrication. So this is the casting. This is just
792 to go.
Well, actually, it's rather more, because they've got. I think they're doing more than 900 altogether, and that's so that you've got 798 for the mirror, and a spare set of actually 133, and that is in order to give you some reassurance that if anything goes wrong, you've got spare mirrors, but also because you have to recoat these mirrors. You what we call illuminize them. We do that at Siding Spring with our big telescope mirrors. And so you might want to be in a situation where you can actually recoat the mirrors, one batch at a time.
Groups of 100 or something.
Yeah, well, that's right, while not losing time on the telescope.
Yeah.
So really big stuff. The important work starts when they start doing the optical surfacing of these mirrors, but they are talking about ramping up to one segment per day when the production process is fully up to speed. So
it's still going to take a couple of years at full tilt to get these
still
things
a couple
made.
Of years.
Wow,
that's right.
That's just
exactly.
incredible. Well, we'll watch with interest, but there'll be more to tell on this story. I just can't imagine what the price tag would be on this thing.
It's of order. It's well over €1 billion.
Yeah. Which is like several thousand billion Australian dollars. Yeah.
That's right. It's a lot of money, and that's why. In fact, there are 3 ELTs planned. This is the biggest of them. The other two, one's being built. Well, the other two are being built by American-led consortia. We are involved with one of them, actually, a thing called the GMT, the Giant Magellan Telescope. They are all smaller than this one and have proportionally smaller price tags. But yeah, it's a big process. We don't envisage there being more than 3 extremely large telescopes in the world because they're so expensive.
Yeah. Of course. They may one day down the track have a crack at that 100-metre telescope if anyone wants to foot the bill, and they're going to call that the FLT.
Well, I think that's the phenomenally large telescope.
Probably is.
Nobody will be able to spell by then.
One would hope not. All right, we'll have more on that story down the track, I'm sure. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Finally, Fred, the incredible growing man, a Japanese astronaut who's been in space for 3 weeks, has sent out a tweet saying he's grown 9 centimetres in height. Now, we do know, because we've discussed this before, that people do grow in space, not like a human grows on Earth as they're growing up, but because of zero-G, they loosen up a bit, I guess. But 9 centimetres?
Yeah, it's a bit over the top, isn't it? So you're quite right that when when your body is not subject to the Earth's gravity, what happens is your vertebrae space out. They become more relaxed. So the individual vertebrae in your spine are not compressed together, and it spaces out, and you grow a bit. And you measure your length, and you realise you've grown. But that's kind of usually measurable over the 6 months of a space flight on the International Space Station. In 3 weeks, to grow by 9 centimetres, which is sort of 4 times more than the average amount of growth. That's extraordinary. This is an astronaut, a Japanese astronaut, Norishige Kanai. He basically made some rough and ready measurements after he's been on mission for 3 weeks. His original tweet was, "Good morning, everybody. I have a major announcement today. We had our bodies measured after reaching space, and wow, I had actually grown by as much as 9 centimetres."
Someone should have told him to take the helmet off.
Well, maybe that was it. But apparently, because the boss of the space station, the commander, who's Russian, Anton Schlapanov, he was skeptical, so they made another measurement, and it's come down to 2 centimeters. He's sent a lovely tweet saying, "I'm very sorry for tweeting out such fake news."
Still, 2 centimeters is a pretty impressive
it is
growth.
That's right.
Would you feel that? Would you notice it?
I suspect with all the other conflicting sensations that you get because of being weightless, you probably wouldn't really notice that. But the reason why his original tweet attracted attention, though, Andrew, was because there was a good chance that if he'd grown by 9 centimetres, he wouldn't be able to fit into the seat of the Soyuz spacecraft that was going to bring him back to Earth. And so he was a bit worried about this. He was actually worried he was never going to come back down to Earth because he'd grown by 9 centimetres.
Well, they just have to build him a new Soyuz and send it up there in 5 or 6 years' time.
Maybe that's right. But
or
anyway,
chop his feet off.
Yeah, or the surgery, something of that sort. But the fact that it's just a mistake, it probably relieved him a lot.
Very relieved. Yeah, very relieved. I'm guessing they'd have to allow for this too when they're working out the transport of astronauts to and from places like this. They'd have to account for these levels of growth, wouldn't they?
Yes, I think that's right. I mean, to some extent, you can squash somebody into a seat, but the fact that your vertebrae are more relaxed and you're basically you've grown, your spine has actually grown. It wouldn't be that easy to crumple yourself up to fit in the seat, especially if you were 3.5 inches taller or 9 centimeters.
Look, I think I know what happened. No disrespect, but physiologically, Japanese people are technically a lot shorter than most other people around the world. So he was dreaming. He was basically, it was wishful thinking. Wishful thinking.
Actually, he's quite tall. He's 182 centimetres.
Oh, damn. There goes that theory.
So throw that theory away right now.
Yes, indeed. All right. Well, okay, 2 centimetres, still an impressive growth span in such a short period of time, but not 9 centimetres as originally reported. But
he's doing pretty well.
Yeah, and how much longer is he up there?
These are normally 6-month stints, so I think he'll be up there for a few months.
Well, maybe it'll be 9 centimetres
by the end of it. Yeah, you never know.
Who knows?
Yeah.
Well, we'll watch this space. Boom, boom. Fred, thank you as always. It's a great pleasure. Thanks for coming back this year. I wasn't sure, but I'm glad you did.
I made it, and you did too. And we'll talk again very soon.
Indeed. Fred Watson from the Australian Astronomical Observatory. There we are. See, I'm rusty too after a couple of weeks off. And as always, thank you for listening. Tell your friends, share us on Facebook and spread us around on Twitter and tell everybody what we're doing. And we'd love to have more people as a part of the crew. We consider you all part of our crew, and ultimately we're going to build a spaceship for all 20,000 of you and go and watch one of those blue horizons during a full moon from like a eclipse from the moon looking back at Earth. That's the plan. I don't know how long we've got. Fred will know, but we'll ask him next week. Thanks again for listening to Space Nuts. I'm out of here.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.